Hey everyone, welcome to another video. In this video, we're going to talk about the code to create indexes, but I want to do things a little differently. And please let me know in the comments what you think about it. Instead of coding live, like that's what I really want to do is like, hey, kind of like the ASMR type thing, like live coding is really satisfying to me. But instead of doing that, I'm going to condense the data and coding videos in the future. I'll still have a keynote, explain what's going on, but then we'll look at the finished code, the finished product. So it might be a little easier to, copy, but hopefully it's just as informative seeing, what's going on. I find that to be the most important piece of any sort of tutorial video is passing not here's what you do, but here's how you think about it. And that's what I'm trying to go in the direction with this static code. So please let me know if you approve or disapprove in the comments, and I will see you after the title. So in this video, we're basically going to replace a SQL script for the name, what table it should be on, the data point list, does it exist or not, and get that file group back. Using the definitions that we created in the last video. And the code is pretty simple. We have a file group function that we will create. It takes in a dataset and definition, and it gets the database, dataset, type, and subject type information to return the file group. And the other piece of code that we need to create actually builds the indexes, iterates through definitions, generates the index name, the data point list, and grabs that file group from the function on the right. Executes everything, and we're good to go. So I'm going to show you what I provided in the description, the comments, and then we'll go over my code. So in the comments below, you will find two sets of comments, one for the file group name function, and the other one for the procedure that will actually create the indexes. So the get file group name for dataset definition, I'm passing in a dataset ID and a definition key name because the dataset ID gives me a lot of information. Definition key name lets me know what type of index I'm actually creating, which will help me decide what file group it should be on. So just declaring my different pieces that I need, the dataset kind of subject of variables, the database subject of variables, the subject type subject of variables, the dataset type name and key name, so we can figure out should it go on relationship index or should it go on reference index, and then the return value, the full file group name, and then we basically build the file group based on pieces of the definition, database, and subject type. So in almost every single video when we're working with datasets, I always get all that dataset information for the dataset ID. And I do it again for the database ID I got back. I need to know what database name and key name we're using. The dataset type, like I said, is it realm, class, family, type, base, or shared? And that will let us know where it should go. The subject type name I am getting from the dataset key name matches the subject key name, and then the database ID just to hit an index that we'll be creating later on. That will give me the subject type name, which will be, relationship, group, or it might actually be reference. So piecing everything together, the file group definition, if it contains cluster, then we're going to return cluster. If it contains columnar, then we will return columnar. And if it contains index, it'll go on the index file group. Now I did this in this specific order because we can get clustered columnar and we want it on the cluster because the cluster is meant to store the table. Then we have columnar indexes and row-based indexes because you can have a table with both of those. So that's why we're separating it and have this specific case order. For the subject type, it's just saying, is my dataset name in shared or base, because I might have to use FG, sysmain, relationship cluster or relationship index instead of reference. But if it's not in shared or base, then it really doesn't matter. It's going to be on reference data. And the file group piece, or the database piece for the file group, is just removing that Hungarian notation, taking DB off of that database name, and then we just put it all together and that will be our file group. And I use concat a lot instead of stuff. Concat is a really powerful tool, and you'll see it again here when we talk about the system object dataset index definition create. It's a mouthful, but I just try to go from most vague to very specific, and a DML if we need. So once again, DataSetId will be coming in, and I will need the dataset type, or the dataset information, database information, definition information, data point information, data point type information, a couple of pieces where the file group name from the function we created, the index name, we need to know what to call it, a data point list, you know, what columns are in this index, and if the index exists or not. And then I'm declaring my SQL scripts, one for does the index exist or not, and we're going to send and pass back a flag. And the second one is for creating the index itself. So again, same thing, getting dataset information for the dataset ID, database information for the database ID returned from the dataset, our SQL scripts for the tokenized scripts, basically, for creating the index with drop existing. That's why we're checking to see if the index exists or not. It's a simpler code. And then the index exists parameters will just be an exist flag bit output. And this is really cool. This is the exist flag thing. Well, if we don't find the index, we're going to get a null, so we're going to return a 0. But if we do find an index, we'll get an index ID, which automatically turns any flag true because we made this a flag. So we could, avoid an implicit convert, but this is small, this works. The more we type, the more errors we make. So now I'm iterating through the definitions for the indexes, the index definition type, and the index definition family of common, or the definition family of common. And I'm doing common because custom is going to call various stored procedures that will look at relationship tables and build clustered indexes based on how we put things together. We do want to automate everything, but in this case, we need clustered and unique indexes on our system before we proceed. So just iterating through those definitions, which will return right now a cluster and a unique index. And oh yeah, I can actually run this for you guys. So those are the two definitions from the last video. The index name is just going to be the abbreviation, which will be CI or UI, followed by the dataset name. And then we're going to build the data point list. Now, how I build the data point list is we're going to call the system relationship table the data that we filled, where the parent is the definition ID because our realm is definition to parent, or definition to data point type. So definition is our parent. And limiting the type ID to this very specific type. Our data point type will be our child. So we'll get a child in order of what we need to create our delimited list. So it passes a data point, and this select code will go to the data point table where the dataset ID and that data point from our relationship match, and it will put them in order. So we'll get specific dataset number because we're concatenating the list object onto itself. So we'll get specific dataset number in, and then it'll pass through, say tenant will go in, and it'll come through, and it will return us a taxonomy ID or a cluster ID depending on what type of table it is. So a very unique thing, not a lot of code. Just closing out that loop for the data point list, and then calling the function I just created or just showed you how to create the file group, replacing the exist script with the index name and the database name, making sure that the flag is null, exists flag is null, and then calling that to get it out. And I'll just scroll up to show you that code again. It's just saying, hey, in this database, if this index name that we just built doesn't exist, it's going to be a 0, or it does exist, it's going to be a 1. So after we execute that if exists index, we need a very large replace script on our index create for the database name, the definition name, which will tell us create unique index, create clustered index. The index name that we created, which will be CI DataSetName or UI TBLRef dataset. Yep. The dataset name, which will be what is it on, the data point list that we built in the nested cursor, and I use the left function to trim the trailing comma off. The exists flag, when it comes back, if it's 1, well, drop existing on. If it's not, if index doesn't exist, drop existing off will create it. This is basically like a drop and create within the create index script itself. And then the file group, where are we going to store this data? So once we execute that, that is that. So thank you very much for watching. Hopefully you don't mind this new format. If you like this video, YouTube will recommend it to users in our industry and subscribe to support me. Thank you very much, and I will see you next time.